Okay, so welcome back. Let's see how we're going to do on timing on this one. I noticed that you guys have a 15-minute break after my talk. I meant like 5-minute break. So, so we'll see. So there's some amount of repeat or same patterns as what we talked about in the last slide, but not too much. And I'm going to go fast. So it's not gonna, I'm gonna skip this one. You've already seen this, right? And I'm just gonna stop briefly right here because even though we did look at this, I just wanna say what we're gonna talk about now is SQL Server R services, right? So we can come back to this chart and say, where does that kind of play, right? So notice we have a collect and manage data, right? That's where SQL fits in. So we have a problem, right? We are sort of, we have a data collection kind of routine in place, right? And we as data scientists, statisticians, machine learning people would like to go and explore that data, would like to go and run analytics on that data, but we also don't want to be yelled at. We also don't want to do anything that's going to put the data in jeopardy, right? So we have different kind of concerns and they come into play. So this is sort of the maybe circles of going back and forth between data scientists, but now pointing to sort of our data collection environment or the place where our data resides, and challenges that come with that. Right? Here's another thing. There's this programming language called R. It seems to be very popular. Right? It's what I learned when I was in school. But back then, it was really just this thing that you learned when you were in school because everybody was using SAS, right? And the big data world has kind of changed a lot of that, right? And so R is now a big thing in industry. Hadoop has changed a lot of that. So because of Hadoop, R is now even bigger than it would have been otherwise, right? And we want to take it and use it because of all the advantages. Primarily, really because of this package ecosystem that's around it. Like R is popular because it being open source means that over the years, so many people have contributed to it, different packages. And these packages do all sorts of analyses from general kind of linear regression algorithms to very specific kinds of time series algorithms that people might use in a very particular subfield and no one else would care or know about. So you can see that R has grown pretty quickly over the last couple of years. And it really stacks up, especially when it comes to doing machine learning. R and Python are really the two giants out there. Okay. And here you can kind of see a brief look at all of the different domain areas where R is being applied. Okay. And these packages that are being churned out by the community are also growing at what seems to be reasonably exponential rate, right? And we want to see what we can do to take advantage of R in a SQL environment. So Microsoft is interested in R. Right? I was working at a company called Revolution Analytics about 2 years ago. Microsoft bought Revolution Analytics because our company was interested in doing big data with R. Right? We realized that R was great, but it had some shortcomings. Shortcomings that had to do with just processing large amounts of data in R. Right? R was limited because it had to load all of the data in the memory in one go, and memory is not as big as hard disk when it comes to storing data. And because R had some other limitations. It was single-threaded, for example. Right? So Revolution Analytics took R and tried to make some changes to it and also contribute to it some packages that would do big data analysis. Since the acquisition by Microsoft, one of the biggest changes, and one of the ones that people are the most excited about, is the SQL integration. And this is what we're going to talk about today. But just briefly, I want to say, first of all, that we have 3 different flavors of Microsoft R. First, we have Microsoft R Open. Right? That's really, for all intents and purposes, I don't want to really get into the detail because I frankly just don't understand it much either, but it's faster because of changes made to the underlying math kernel library. And it's also faster because it's multi-threaded. Right? So right off the bat, the same code, the same R code, no changes, is going to run faster in Microsoft R Open. The R server is what we're concerned with here, and that is basically the same Microsoft R Open, but now there's some additional packages. And those packages allow us to do big data stuff, and they allow us to do it in remote compute context. What that means is that we're working from a client machine, which could be our laptop, and we have some R code, and we have our R IDE, right? That could be Visual Studio or RStudio. And we want some computation, not all the computation, but some computation, especially the ones that's going to go and hit the big data, to go and happen in a remote machine that is hosting the big data. And nowadays, that's mostly either Spark or SQL Server. So the R server does that. There is also an R client. The R client is a lightweight version of the R server in the sense that the same packages that are on the R server, those big data packages I just talked about, they're also on the R client, and we can use them. We can experiment and develop with them. We can see how they work. We just can't use our own client laptop as an R powerhouse. It's lightweight. But one thing that we can do with the R client is we can actually take our code using the R client, do our stuff from our laptop, and then we can communicate from the client, from the R client to the R server and run some stuff inside of SQL. Okay, so here's where the data scientist is coming from. It says, I like R, has a lot of packages, it's very promising, it's very quick. Right? That's really the big thing about R, is going from raw data to some kind of visualization, analysis, some kind of model takes very little typing. Usually within just 10 or 15 or 20 lines of code, you can accomplish a lot of things in R. Even when you limit it to 80 characters per line. Right? So I'm not exaggerating when I say that. But they're concerned. Probably the number one thing they're concerned about is scaling, first of all, because now I don't have data just on my laptop. I have data in very in remote environments, and the data sets are very large. And the other thing is actually putting this to production, deploying it, right? So if we have to deploy a model, what is the turnaround time, and how much does the data scientist have to get involved in that? Then we have developers. Developers are trying to build intelligent apps using machine learning, and they have heard about R. They don't really maybe know how to use it or care to learn how to use it because they are not going to do machine learning, but they're interested in taking advantage of it. Maybe they have data scientists that they want to go to and say, hey, can you put something together in R, and I want to use it inside of my application. And once again, the developers is going to have, to some extent, the same concerns that the data scientists had, and in some ways also like a different way of looking at it. Like, so a developer is very interested in integration in addition to scaling and performance, right? So we need to see how we can cater to the developer as well. Finally, we have the DBA. Right? Now the DBA probably hasn't even heard of R. Right? But what they are concerned about is the data. Right? Is the data safe? Are you copying the data on your laptop and going around when you shouldn't? They're also going to be concerned about scale and performance, not necessarily in this case the scale and performance of the machine learning algorithm, but the database, right? Is the machine learning algorithm putting a lot of strain on the resources of the database? When you talk about in-database analytics, which is what we're going to see in action, that's a big concern, right? Same thing with sort of data fragmentation, right? If we have different teams and everybody's kind of working with a copy of the data on their laptops, this is going to cause problems later down the road. Okay, so we're going to see how SQL Server R services can address the concerns of all three players in this setting. Right? And we're going to learn about the two different ways that our server can run, or our services can run in a SQL Server context. One of them, I call it the data scientist scenario. And this means more of an interactive kind of environment. That is, we have a data scientist, there is some data in SQL, they would like to go and explore that data. They might not have any particular application in mind yet. They might just be interested in doing what's called EDA, exploratory data analysis, creating charts, visualizations, asking questions about the data, and just getting a good feeling about what sort of data is in there. Then we have more of a production scenario. This is where the developer is going to be very interested in, which is, how is my application going to communicate with R? How is this application going to be put to production? How well is it going to, or how do I basically monitor the application, and so on, right? So the production scenario is the second way that we can use our services, and we'll look at that. But let's start with the first scenario. Right? This is the data scientist on the left side of the screen sitting on their client machine. They have R, they have the Microsoft R client, and they have an IDE for R, because if you use R, you are probably using some kind of IDE because of just how much they make it easier to interact with R. But then we have this thing on the right side. That's the SQL Server machine. And as it turns out, this is also hosting a version of R. Now, the one on the left is the R client. The one here is more like the server version of R. That's the powerful R. At a very high level, the kind of back and forth that's going to happen is going to start like this. The data scientist on their machine has some R code, but that R code is pointing to data in SQL Server. And it's also going to run some analytics on it. In this case, you can see a little example, 3 lines of code that end up with rxlinmod, which is the R function in the R server for building a linear regression model. Right? So the code is sitting on the left, the data is sitting on the right. Where do we want the computation to happen, by the way? It depends, but if the computation is happening on the data on the right, as much as possible, we want the computation to also happen on the right, right? This is called data locality, right? We want the computation to happen where the data is sitting so that data doesn't have to transfer over the network. Okay, so computation here, by the way, thank you for saying that. It depends. When I say computation, I'm talking about computation on the data in the SQL Server, right? Not every computation has to happen on the right. If it has nothing to do with the data, it can happen on the left, and you don't have anything, any worries about using our services. Okay, the execution happens on the right then, and out of that execution, we get some results. Right? A result could be a visualization. A result could be, in this case, a model object, a trained model, like the kind of things that we saw in the last talk. And those results are going to travel back to us, to our laptop, to our local machine, where we can further interact with them, further explore them, and such. This is the second scenario. This is more the application scenario or the deployment scenario. Now we have an application. That application is going to make a call to our services via a stored procedure. So it's using the same kind of mechanism. I am not a SQL expert, but I would probably, correct me if I'm wrong, but using the same kind of mechanism that applications should be using to make calls to SQL. Right? SQL is going to invoke R. There is no second R in this case. There is no client. There is just one R, and it's sitting on the database. that R is going to process some data in the database and generate some results. Once again, it could be images, it could be modeling objects, it could be anything. But in this case, it's probably not going to be an R object. It has to be something that the application understands. Right? Unless the application understands R, it has to be something else. So a plot is maybe a more useful thing to think of conceptually here. And that travels back to the application. Okay, so I'm going to go to a data science virtual machine that I provisioned just about 2 hours ago. And the nice thing about this virtual machine is that everything is pre-installed, so we don't really have to do anything. We can just take our code and run it. The one thing that I did have to do is just, and I can show that to you right here. So I launched the Management Studio, and I ran just a little bit of, just a short script that is going to ensure that our services is enabled, right? And then another set of scripts that create a username and password that I can use to launch our services jobs. Okay, so this is pretty much just setting up the environment. And I'm going to go back to the Visual Studio IDE in this case, and we're going to look at both architectures. One, the data scientist scenario. This is what we're going to spend most of our time looking at, just because it's the one that most people are unfamiliar, especially thinking about the audiences that come to this sort of talk. A lot of people come more from the SQL background, wondering what our services is and how they can use it. And they usually come back to me and say, I had no idea that you had these two ways of doing things. I thought the only way of doing things was like the stored procedure. So we're going to see just some of the ways that we can use our services, or more specifically, the data scientists should be using our services. But at the end, we'll look at one example of a stored procedure and talk about the use case there. Okay. So what I'm going to start with is, this is, by the way, Visual Studio. I am using R tools, and I have my R console on the bottom of the screen here. I have the R code at the top, and I'm just going to select the code and chunk by chunk send it to the console. And when I select it, you can kind of see which part of the code is running as I'm doing this. Okay. So the first thing is we're going to point to a CSV file that's on the data science VM. And I'm going to point to SQL Server using a connection string. So you can see the connection string here. You can see that the username is ruser, and so is the password. This is going to make your DBA your worst enemy. But for demos purposes, it's fine. And in this line that I've selected, I am pointing to some data in SQL. Right? So from the R end, this is how we can point to data in SQL. There is a function called rx SQL Server data, and you just give it the connection string, the name of the table, and then there's this useful kind of thing here called rows per read. This is because Microsoft R Server functions are distributed. What that means is that they can process data chunk by chunk. They can take data and turn it into, in this case, chunks of 100,000 rows, and they can process the data chunk by chunk. This gives us scale and performance. This makes it so that we don't put too much strain on SQL Server when we process large amounts of data using the R server. Okay. And for now, let's assume that that data doesn't even exist, right? We're just pointing to data. We don't even know if that data exists or not. In fact, in this line, in this chunk of code that I've selected, we're going to take the CSV that we were pointing at a little bit earlier, and we're going to dump that in SQL by just giving it the pointer to the data in the previous line. Right? So this function rxDataStep says, here's some CSV file. Here is a pointer to data in SQL. That's the word I like to use, pointer. I think when you say pointer, it becomes clear that there is no overhead. It's just pointing to some data. and it's going to go read from the CSV and dump the results in SQL. Now that it's in SQL, we can pretend that it was always there. Right? Most of the time, data is already sitting in SQL. We don't have to do what we just did. And we can go and query that data. So here's a very basic query for that data, and it says, show me just the top few rows of the data, and show me the column types. Right? Now, these are not SQL column types. These are R column types. I think that's one of the things that's going to cause the most amount of confusion to people trying to wrap their head around this. Is we have SQL column types. For the most part, they translate into the same column types in R. If you have something that's an integer in SQL, it's going to become an integer in R. If it's numeric, it's going to become, or if it's a float, it's going to become a numeric in R. The one case that gets tricky is the one that we're going to see in just a second. So there is a function called state. Right? We expect this to be the states, labels for the states, but we can see that in the data, it was stored as these integers. So these integers probably map to individual states, but even if we knew what the mapping is and we were very comfortable with the integers, if we ask for a summary of the state column, which is what's happening in line 54, what we get is some averages and standard deviations, right? Things that we don't expect to see. Right? We don't want to see an average. The average doesn't make any sense because the integers don't really have any significance other than mapping to individual states. So in R, we would say that column needs to be a factor. What I mean by that is it has to be treated as categorical data. Right? So R has a unique column type called factor, which is reserved for categorical data. And if we take care of, as part of taking care of our data, we have to take care of these factors. And that's probably the most important thing that we have to do initially when we work with data in SQL, is just make sure that if we bring data into R to do something, that when something is a factor or needs to be a factor, that we treat it as such. So we have two chunks of code there, right? And it looks kind of straightforward what's going on, right? We have the state labels at the top there. And then we create this complicated looking nested R object, but it's really allowing us to control metadata level when we deal with data on SQL Server. Right? So in this case, we're telling it, well, yes, we have a column that is called gender in SQL, but its type, I don't want it to be an integer, I want it to be a factor. In the data in SQL, when you go and look at it, you're going to see ones and twos. But when you present the data to me in R, I want to see male and female. I want to see data that is not necessarily stored as integers. It makes sense for a DBA to store data as integers because it's more efficient, right? But for a data scientist, we want to see the labels, the proper labels. We want things to be pretty, right? Because out of the data, we might create plots and visualizations. If we have these integers, our plots are not going to be properly labeled. Right? So we create that metadata object, and we go back to pointing to our data, but this time we add this little piece to it. We say, here is information about the column info or the column types. I want you to treat each column in this particular way, or at least the ones that you care about. It doesn't have to be every column. Now when we look at our data, the same data, and we can see proper labels for gender, state, and cardholder. Right? Let me be clear, nothing changed about the data in SQL. Right? This is all the way that it's being treated in R. Right? We didn't go back to the data in SQL and change what used to be a 0 into a male. We just present it in R in this way. Right? We don't want to do that sort of thing because we don't want to mess with the data. We want to take the data and use it for data science without necessarily changing its underlying structure. We're not the only game in town. Other people are using the data, right? And so as much as possible, we don't want to get into each other's way. Okay. I'll probably skip this. You can run it on your own. I'll show you the I think in the slides I have the repo, but just in case, I'll show you at the end where you can get all of this code and run the examples. But we can do more than what we just did. We could go, for example, to this state column and say, you know what, in the data, I have information about all 50 states, but for my analysis, I only care about the top 5 largest states or the top 7 or whatnot. When you bring the data into R, if you see any states other than the ones that I've listed in line 87, then pretend as if they were nulls in SQL. Right? Again, no change happening to the data in SQL. It's just the way that the data is being brought into R that is changing. Okay, so I'm going to skip some of this, and I'm going to come here to the next thing that we have to do. So far, we were able to point to data in SQL, but one thing that we haven't done is we haven't specified where computation needs to happen. Right? Just because the data that we're pointing to is in SQL, R doesn't assume that we want the computation to happen in SQL. It seems kind of a logical thing, but it doesn't necessarily follow, because sometimes we really don't want the computation to happen remotely. So we need to be a little bit more explicit, and so we have this thing called a compute context. In the second chunk of code that you can see in line 107, we're creating a compute context for SQL. A compute context is basically a fancy way of saying where computation is happening. Right? And in this case, we're giving it back that connection string and some other information so that we can say, here is where SQL is. And then in line 110, we set the compute context to SQL. That's our way of telling this local R session. Right? Imagine what we're looking at is a client R session. We're telling it computation needs to happen in SQL. Okay. And the get is just to check the compute context. If you don't remember what it is, you can run the get, and it says your current compute context is SQL. Yeah. Okay. So again, in the interest of time, I'm sorry, I have some things I'm going to skip over to take you to the more interesting things. So just to be clear, I'm going to set the compute context back to local. Right? This is what it is by default. And I'm going to do this to show you the 3 different ways that things could happen. First of all, here's something we can do in local. We can say, I have some data locally. It's a CSV file. It has nothing to do with SQL Server. Can you give me a summary for the 4 or 5 columns that I've listed here for that CSV file? And it says, sure, no problem. Here's your summary. The average for balance in the data set is about $4,075. I could say next, my compute context is still local, as you can see in 129. And I could go back and run that Rx summary function again, the same one that returned this result, but now point it to the data in SQL. Notice the last piece of line 130 says SQL fraud DS. Okay, that's the data in SQL, but the compute context is local. Right? This is usually the kind of thing that we don't want to do, because what this is going to do is, first of all, it does seem to work, right? But what happened is we said the computation has to happen in the local machine. The data is remote. It went and fetched the data, brought it over to the local computation. This breaks data locality. And if the data set was big, this is the point where you would basically be waiting around for things to happen, right? So to overcome that problem, we're going to set the compute context to SQL and run the exact same line of code, and it doesn't look any different, right? For the most part, it's the same kind of look and feel. Notice there was a slight lag. Right? The lag is because there is some communication that has to happen. The lag is a small cost to pay. compared to the cost of what it would take to transfer the data if you have very large data sets. Right? So this computation, this last computation, is what happens in database. Right? So two things have to happen in database: set the compute context to SQL Server, and then point one of the R server functions to the data in SQL Server, and your computation happens remotely. Okay, so what we're going to do next is we're going to look at some examples. Let me just see what we're doing. So we have about 10 minutes. We're going to use the next 5 minutes to look at just a few more examples of things that we can do from this end, from the R IDE, from our R client. And then the last 5 minutes, we're going to use that to go to the SQL Server Management Studio and look at some, or one example at least, of a stored procedure that is invoking R. Okay. So for me to do that, I'm basically going to skip over a bunch of stuff in here and take you to maybe the most exciting example, which is the modeling example. Okay, so in here I have a lot of different examples of like running statistical tests and so on. Right? One thing I should mention is that in a lot of these examples I use the R server functions, the big data functions for processing the data. But you should know that you can use any open source R function to do in-database analytics. Right? And there is a particular way of doing that using a function. So I'll show you maybe just this one example. So there is a function called rxexec. Right? This is a R server function, but it says its job is to take any open source R function, right? Any function you want, and it's going to run it. But because it's an R server function, before it runs it, it's going to look at the compute context. It's going to say, where does this computation need to happen? And if the computation is happening remotely, and if the data that you're pointing to it is also remote, it's in SQL, then that computation is going to happen remotely. Right? So most of the examples that are in here are using directly the R server functions. And for those, we don't have to do anything. It just looks at the compute context and does its magic. Open source R functions are not aware of the compute context. They need to be explicitly, we need to run them explicitly in the remote compute context, which is what the rxexec function does for us. Okay, I feel like I'm talking a mile a minute. Let me just catch my breath. Okay, so we're going to take a look at just an example of using our services. So just to remind you, this is our data. Right? We have a data set with some information. It's information about basically fraudulent transactions. So you can see a customer ID in the first column, some demographic information about how much money they have on their accounts, and the number of transactions, and the number of international transactions, and I guess this is some kind of measure of how much debt they have. And finally, the last one, going back to the last talk we had, that would be our target, fraud risk. So we have historical data about fraudulent transactions. We're going to use the historical data to build a model that hopefully will tell us about future transactions' potential of being a fraudulent one. If we ask for a summary of the fraud risk column, we can see that the great majority, the lion's share of transactions are not fraudulent. There is only about 600 transactions in this data set of 10,000 transactions that are fraudulent. And the model we're going to build is one that we built in the last talk using the Azure ML interface. Now we're going to build it using the R programming language and the R server library in the R programming language that can run these models on data in SQL. Okay. So the function is rxlogit. It's a logistic regression model. It's going to do classification because we want to know if it's fraud or not fraud. Right? And when we build the model in SQL, we just have to specify these two lines, right? So the compute context is already set to SQL. All we need to do is, in this case, run the rxlogit function. The rx prefix tells me that this is an rserver function. And when you run it, you get a model object back. And these numbers that you can see in the first column under estimate, those are basically the numbers that go into creating that equation that does our prediction for us. So we have a model object. We can go and look at some example of predictions. Right? So in this case, we're going to create this kind of dummy data set, this small data set that has some examples of balance and credit line. We want to see if, notice that our model is being built right here. It is going to predict fraud risk using balance and credit line only. Right? So we're going to go on that sort of small data set that we created over there, and we're going to run our predictions on it. Okay. We need to set the compute context back to local because that data set is just a dummy data set we created in our current R session. It's not in SQL. And we run this function called rxpredict. If you remember the last talk, which all of you do, that would be the score model function module. Right? Rxpredict is going to go and take a data set and a model object. The model object is modlogit. The data set is preddf in this case. And it's going to give us the probability of a fraudulent transaction. When we look at that data, we can visualize it in R using ggplot2. And let me just make this a little bit bigger. This kind of fancy looking plot comes out. So it says basically, if you want to predict fraud risk, you can look at balance, right? But if you take credit line into account, credit line is a measure of how much debt they have, then some interesting things come out. They say if you have next to no debt, then knowing your balance doesn't really help you in deciding if you're fraudulent risk or not. Not that it doesn't help you, but this model says if your debt is low, then my prediction is going to be low across the board, regardless of your balance. By the same token, if your debt is high, then once again, regardless of your balance, the prediction is high across the board. The one that's really interesting are probably the three lines in between where we can see some kind of relationship going on. So if you have moderate debt, then higher balance means you have a higher probability of a fraudulent risk, and lower balance means a lower probability. Okay, so that's the model. And now in the old days of just using R on our local machine, we would usually do something like this. We would say, I spent a lot of time building this model. It took me a lot of back and forths. I have to look at a lot of evaluation metrics and so on. I am happy with this one. I'm going to save it. And this way, I don't lose it. If my R session crashes or whatnot, I have this model object that I can always load. Now we're in SQL Server, right? And we can do something really neat in SQL Server. Right? If we're talking about saving this model object, there are two problems. First of all, a model object contains a lot of intellectual property. It's not just data that's important. These objects are really important. What if this is a model that's going to predict your credit score, right? The credit card, what are they called? The Experian and the other two companies whose names I can't remember right now, are very protective of that sort of information, right? So this is important information. It's a modeling object that contains intellectual property as far as we're concerned. And if we save it, well, we might not be very happy about saving it on our laptops, right? So that's one problem. And if we want to save it on the server, the DBA might not be very happy about us saving random things on the server, right? So in SQL Server, we can do the following. We can say, I'm going to take this R object and serialize it. That means I'm going to make it look like gobbledygook to the human eye. And what I'm going to do then is I'm going to save the modeling object in SQL Server. I'm going to insert it in a SQL Server table. So for that, there is already a little macro that's in place, a little stored procedure called persist model. And persist model is going to take an R modeling object and it's going to insert it in a pre-existing SQL table for us. That table was already created when I ran sort of the code to set up the environment, but we can go and take a brief look at it here. So we created a table called models in SQL Server, and we said that it has one column, and that column is var binary. Right? That makes it possible for us to take a serialized R object and place it in here. We're running out of time. I thought there was like a 15-minute break after my talk, right? No, there isn't? Okay. All right, give me like 2 minutes. 2 minutes. And then this is the stored procedure persist model. And notice that really all it does is just inserts into this table. The nice thing about the stored procedure is that we can invoke it here from R. We can say, here's some SQL query, and I just want you to run it in SQL Server. Right? And the reason we want to invoke it in R is because the object itself, the model object, is in R. So we want the query to populate itself in R and then send it over to SQL Server so that it can execute. If I go to my tables and I look at RDB, which is the database I'm using here, and I look at, my tables under models, I can just do a select, and I can see the object here in R. Okay, so this is great. This means that we were able to take an R object and store it in SQL Server. We can now come to this last little example here. We can invoke that object. We can go and pull it back out, deserialize it or unserialize it. Right? And the way we're going to do it is through a stored procedure. We can actually do it from the R server too, not a problem. But we stored it in SQL so that we could show that you could have a stored procedure that says, you have a model, now we can use it to make predictions. And this stored procedure could be invoked by any application. Right? It's a stored procedure, so it's basically sitting there. Applications can call it. It is going to invoke R. R is going to go to that table where we stored that R object, the model object, and it's going to unserialize it so that it goes back to being something that R can understand. And it's going to, in this case, make a prediction. Notice here is the rxPredict function again. Right? So let me just quickly run that. And I guess it's F5. And in the last line here, we're going to invoke that stored procedure. It takes just a little moment, but here is the stored procedure using R to make predictions from the model on a data set that it is pointing it to. Okay. So we kind of saw an end-to-end scenario. The data scientist was able to use R. It was able to create an R object. It was then able to go and store it in SQL. The data was sitting in SQL the whole time. Nothing happened by basically breaking data locality. And at the end, it was able to go and save the model in SQL, and an application was able to invoke this stored procedure and make predictions using that model. Okay, so I think that is all that I have. Let me check. Yeah, the end. The end. All right, thank you very much.